Today's topic is whole numbers divided by unit fractions from Unit 6. By the end of the lesson, you'll be able to calculate the quotient of a division equation when a whole number is divided by a unit fraction by creating an area model and performing the correct steps of the algorithm. You'll know you'll have it when you see the results of the algorithm and the area model of the equation are the same. Some vocabulary that you'll want to know is unit fraction, a fraction with a numerator of 1, area model, a visual representation of a mathematical operation. The anchor charts for this topic look like this. This shows you an example of an area model that goes along with an equation, as well as a number line, and then it shows you the steps of the algorithm that you can take to solve this equation. So let's look at an example. We have a whole number divided by a unit fraction. Our whole number is the number 4, and our fraction is 1/5. To create an area model, I'm going to create 4 wholes because that is what my whole number is, 4. 1, 2, 3, 4. Next, I'm going to look at the denominator of my fraction. Whatever that denominator is, that's how many pieces I'm going to split each whole into. So we have a denominator of 5 in our unit fraction. So that means that each whole I'm going to split into 5 pieces. 1, 2, 3, 4. 4 lines create 5 pieces. So I'm going to do this to each whole that I have. Now you can see that each one is split into 5 pieces. To find my quotient, all I need to do is count the total number of pieces I have created, and that will show the answer to my equation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20 pieces total. Therefore, my quotient is going to be 20. Now, if you prefer to do this on a number line, I would do the same thing as I've done with my area model. I start at 0, and my number line is going to end at whatever my whole number is. In this case, it is 4. I'm going to split my number line into that many pieces, and then I am going to split each section into the number of pieces dictated by my denominator. I then count how many lines I have created. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Both of these represent the quotient to my equation. Now, I can draw an area model if I need a representation, a visual representation of my equation, or I can follow along with my algorithm to solve as well. In this case, when we have a whole number divided by a fraction, I'm going to follow KCF, keep, change, flip. So I am going to keep my whole number the same at the beginning, and I'm just going to place it over 1. 3 over 1, because I know, oops, not 3. It should be 4, because that's what my whole number says. So I'm going to do 4 over 1. I'm going to change my division sign into a multiplication sign because I'm going to do the inverse operation, because I'm going to flip my unit fraction. Now I've created an equation where I'm multiplying fractions, and when I multiply fractions, I know I just multiply the numerators, and then I multiply the denominators. So 5 times 4 is 20. 1 times 1 is 1, and I know any number over 1 is a whole number. So essentially, I have found that 4 divided by 1/5 is 20. Continue on for more practice problems to follow these steps.